Welcome to this episode of Robert's Creative Chronicles. So today, we'll be solving these exercises on complex numbers. We'll start with the first one. So solution. The first one, given that z1 is this, z1 is 7 minus 5i, and z2 is 2 minus 3i. Find z1 plus z2. So z1 is, we'll say number 1, z1 is 7 minus 5i, z2 is 2 minus 3i. Now we'll do a z1 plus z2, that means we'll add them together. This is the addition of complex numbers. It is done by adding each component of x and y. So 7 minus 5i plus 2 minus 3i. So we'll add the x component, 7 plus 2, and then we'll add the y component, which is the imaginary component. And this x component is the real component. 5i minus 3i. So this will be equal to 7 plus 2 is what? It's 9. Then minus 5 minus 3 is what? Minus 8. No, this is 9 minus 8i. So I'll be showing you a quick method. You can actually cross-check this using your calculator. All these addition, subtraction, multiplication, division of complex numbers, you can actually cross-check them using your calculator. So we'll put complex mode first, then to be 7 minus 5. Here is I, so it will be shift I. So 7 minus 5i plus 2 minus 3i. This is 9 minus 8i. That's what we got. So you can, if you get it, you can try cross-check it using your calculator. The second one is z1 minus z2. So it is, so this is z1 plus z2. Here is z1 minus z2 equals 7 minus 5i minus z2 is this, so it's 2 minus 3i. So this will become 7 minus 5i minus 2 plus 3i. So now we'll put the two real components together and we'll put the two imaginary components together. So these components together, then 7 minus 2 is what? Is 5. Then minus 5 plus 3, that is 3 minus 5 is minus 2. So it's minus 2i. You can also cross-check it using your calculator. So it's 5 minus 2i, you see. So let's move to the third, maybe the C part. So the C part is z1 multiplied by z2. So it will be 7 minus 5i multiplied by 2 minus 3i. So this becomes 7 times 2 is what? 14. This times this is minus 21i. This times this is minus 10i. This times this is minus times minus is plus. 5 times 3 is 15. I times I, you know I is root of negative 1. So if you times them together, it will be I squared. That is the root of negative I squared. So it will give us minus. So this minus will appear here, because this and this will cancel. So there will be minus 15. So this becomes what? 14 minus 15 is what? Minus 1. Minus 21 minus 10 is what? Minus 31i. So this is it. Now we can cross check it. using -1 minus 31i. So then this d part, z1 over z2 is what? 7 minus 5i over 2 minus 3i. So in this kind, we have to find the complex conjugate of the denominator. The complex conjugate of the denominator will multiply it by the numerator and the denominator. So it will be 2 plus 3i, that's the complex conjugate of this, over 2 plus 3i. No, this times this is what? 14. Then 7 times 3 is what? 21. 14 plus 21i. Then this is plus 21i. Then this is minus 10i. This one will give us minus 15. But there's a minus that will come here because of I squared. So it will be plus 15. Then divided by. No, now this one, since it's a multiplication of difference and there's a formula for this, since the sign only is minus and plus, so it will be 2 square 3 minus 3i square. So we'll say 2 square. 2 square is what? 4. So minus 3i square is what? Is minus 9. So this becomes what? 14 plus 15. 29. This is 29. 21 minus 10 is plus 11i over, this is 4 plus 9, which is 13. So this will become 29 over 13 plus 11 plus 11i over 13. That is z1 over z2. Since so this will be the real component, which is x, and 11 over 13 is the imaginary component, which is y. So we can cross check it. 7 minus 5i over 2 minus 3i. So you see 29 over 13. So you see 29 over 13 plus 11 over 13i. So all this is correct. If you are doing maybe an OBJ exam, you can use this calculator for it to get the answer quickly. But if you are doing an AC exam, this workings is compulsory for you to show it. Because you cannot just say z1 over z2, you put this and you put the answer. You will not get any mark. You will only get the mark for the final answer. So this is the second exercise. It says we should write this expression in this form. So now we will work it. We open the bracket, it becomes 3 minus 7i minus 6 plus 6i. So we put the real components together and the imaginary components together. So 3 minus 6 minus 7i plus 6i. 3 minus 6 is what? Negative 3. Then this one will be 6 minus 7, which is minus 1. And that is minus I. So this is the form where x is equals to negative 3 and y is equals to negative 1 according to this form. So this is x and y is minus 1. So we have successfully expressed this expression in this form. So we can use our calculator to check. The negative 3 plus will be negative 3 plus 7i plus negative 6 plus 6i. So it's negative 3 negative I. You can see. Then the third exercise, it says we should express 1 plus I raised to the power of 4 in this form, the same form. So we'll work this. This becomes 1 plus I, 1 plus I, 1 plus I, 1 plus I. So let's open this first. 1 times 1 is what? 1 plus I plus I plus minus 1 because of I square. Then here also will be the same thing. So it will be 1 plus I, 1 plus I plus I plus minus 1. So this will be what? 1 minus 1 is 0. So it will be 2i. Here also will be 2i. So 2 times 2 is 4. I times I is negative 1. So this now will be negative 4. But the question says we should express this. The question says we should express this in the form of this x plus iy. So this answer is only for the real components, that is x. So since we want to express in this form, we'll say plus 0i because the imaginary component is 0. So now we have expressed it in that form where x is negative 4 and y is 0. So this is the final answer. Then the fourth part, it says we should solve for x and y in this, where x and y are real numbers. So this is it. So now, when two complex numbers are the same, that is z1 equals to z2. When two complex numbers are the same, it means that x, that is the real component, that is x1, is also equals to x2, and y1, that is the imaginary component, is also equals to the imaginary component. That means for these two complex numbers to be the same, the real component must be the same and the imaginary component must be the same. So we will equate their real and imaginary components because this complex number has been equated to this. So now this one is the real component, this one is the real component. So 3x will be equal to negative 9. Then x now is equal to what? Minus 9 over 3, which is minus 3. And this one also, the imaginary component now, 6 is equals to 2y. So you divide both sides by 2. Y will be equals to 3. So that's it. And this one, you can also cross-check it using your calculator. You say 1 plus I. And in this one, if you put the power of 4 directly like it is here, you will not get the answer. To just give you an error. So you will have to just be putting it like this: 1 plus I, 1 plus I, 1 plus I. So you see, negative 4. That's the answer. So you can, in complex numbers, you can always use your calculators to confirm the answer. And this one, this one, there are some expressions like this that gives us simultaneous equations, maybe 2, for us to solve. When you equate this, maybe when there are two variables, maybe there will be x, maybe here will be x plus y in bracket 3x plus y, then here. So this will give you, those ones can give you simultaneous equations. So this one is direct, it just gave us the answers individually. There are some that will give you simultaneous equations, and you will solve them using different other methods like elimination, substitution methods. So these are all the solutions of all the exercises on complex numbers. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.